In this video, we will solve some word problems related to pair of linear equations in two variables. The first question that we will solve in this video is, a fraction becomes 9 by 11 if 2 is added to both the numerator and the denominator. If 3 is added to both the numerator and the denominator, it becomes 5 by 6. We need to find the fraction. So a fraction has two components, that is a numerator and a denominator, and both of which are missing in this particular question. So the first and foremost thing that we will do in order to start our solution is assume the two components, that is the numerator and the denominator. So we'll assume, let the numerator be x and the denominator be y. So we'll assume the numerator to be x and the denominator to be y. So that means our fraction will be x by y, numerator by denominator. So we simply need to find the value of x and y, then we will have our required fraction. Here two cases are given to us with which we can form two linear equations and then solve them in order to find the values of x and y. In the first case, it has been given that fraction becomes 9 by 11 if 2 is added to both the numerator and denominator. So let's form a linear equation using the first case, which is if 2 is added, that means we'll add 2 to the numerator and 2 to the denominator as well. Then it has been given that the fraction becomes 9 by 11. Now let's solve this equation in order to get the first required equation. 11 into x plus 2, 9 into y plus 2. 11 into x will be 11x, 11 2s will give us 22. 9 into y is 9y plus 9 2s are 18. Now let's bring variables on one side, 11x minus 9y, and constants on the other, 18 minus 22. So the first equation that we have got from the first case is 11x minus 9y equals to plus minus minus, 22 being the bigger number, minus sign will retain, 22 minus 18 will be 4. So minus 4. 11x minus 9y equals to minus 4 is the first equation that we have derived by solving the first case. Now on to the second case, which says if 3 is added to both the numerator and the denominator, that is the fraction becomes 5 by 6. So in case 2, we will add 3 to the numerator and 3 to the denominator as well, and the question has said that the fraction will become 5 by 6 on doing so. So x plus 3 divided by y plus 3 will equate to 5 by 6. Let's solve this in order to get the second linear equation. So on cross multiplying, 6 into x plus 3 equals to 5 into y plus 3. 6 into x are 6x plus 6 3s are 18. On the other side, 5 into y is 5y plus 5 3s are 15. Now let's bring variables on one side, 6x minus 5y, and constants to the other, 15 minus 18. 6x minus 5y on the left hand side, 15 minus 18, 18 being the bigger number, minus sign will retain, 18 minus 15 will give us minus 3. So our second equation is 6x minus 5y equals to minus 3. Now we have derived both the linear equations, and now we can solve them using any of the algebraic method. So far we have learned elimination and substitution, so we'll stick to one of it. For this particular question, let's go with elimination method. Now in order to cancel x here, the coefficients of x are 11 and 6. So that means the LCM of 11 and 6 will be 66. And if we want to cancel y, then the coefficients are 9 and 5. So the LCM will be 45. Let's cancel x. So for that, we'll multiply equation 1 with 11. 6 will give us 66. So we'll multiply equation 1 with 6. And equation 2, we have coefficient of x is 6. 6 11 there will be 66. So equation 2 will multiply with 11. So let's just write it in words. Multiplying equation 1 by 6 and equation 2 by 11. 6 11s will be 66. So 66x minus 9y into 6 will be 9 6 is 54. So minus 54y minus 4 into 6 will be minus 24. Now multiplying 11 with equation 2. 11 6 will be 66x minus 5y into 11. 5 11 is 55. So minus 55y and minus 3 into 11 is minus 33. Now we have got the coefficients of x equal, but the signs are also same. So in order to make the signs opposite, we will subtract the two equations. While subtracting, the sign of the lower equation gets reversed. Had the sign already been opposite, we would have added the two equations. So on subtracting, plus 66 in the lower half will get converted to minus 55y will get converted to plus, and minus 33 will get converted to plus. Plus 66 minus 66x equal and opposite, so it will get cancelled. 55 minus 54 will give us 1, and 55 has positive sign, so plus sign will retain. 1y, or simply we can write y, equals to 33 minus 24 will give us 9. So the value of y is 9. Now we can use this particular value in either equation 1 or equation 2 in order to get the value of x. In order to get x, let's put the value of y, which is equals to 9, in equation 2. Equation 2 is 6x minus 5y. 6x minus 5, in place of y we will write 9 equals to minus 3. 6x minus 5 nines will be 45 equals to minus 3. Now let's shift 45 to the other side. We will get 6x equals to minus 3 minus 45 to the other side. We will get plus 45. 6x equals to 45 minus 3 will give us 42. Now finally, x equals to 42 by 6. Cancelling 42 by 6, 6 1 is 6, 6 7 is 42. So the value of x is 7. We've got the value of x, which was supposed as the numerator, and the value of y as 9, which was the denominator. Hence we can conclude that the required fraction is 7 by 9. Now moving on to the next question, which involves age-based problem. 5 years hence, the age of a person named Jacob will be 3 times that of his son. So this is given in the first case, and in the second case we have been given that 5 years ago Jacob's age was 7 times that of his son. We need to find or determine their present ages. So let's start our solution by assuming their present ages. So let Jacob's present age be x years and his son's present age be y years. So we have assumed their present ages to be x and y years respectively. Now in the first case, we have been given that 5 years hence. That means after 5 years. So 5 years hence, or in other words, after 5 years, Jacob's age, since Jacob's age presently is x, so after 5 years, Jacob's age will be x plus 5 years. Similarly, his son's age presently, which is y years, will be y plus 5 years, 5 years hence or after 5 years. It has been given to us in the question that 5 years hence, the age of Jacob will be 3 times that of his son. That means, according to question, 5 years hence, Jacob's age, x plus 5, will be 3 times of his son, 3 times of y plus 5. Let's simply solve the equation in order to get the first linear equation. 3 into y will be 3y, 3 5s are 15. Let's bring variables on one side and constants to the other. X minus 3y equals to 15 minus 5 will be 10. So this is our first equation. Now in the second case, it has been given to us that 5 years ago, Jacob's age was 7 times that of his son. Now case number 2. Case 2, which is 5 years ago. Presently, Jacob is x and his son is y. So 5 years ago, Jacob's age will be x minus 5 years, 5 years less. Similarly, his son's age, which is presently y, will be y minus 5 years, 5 years less. According to question, it has been given to us that 5 years ago, Jacob's age was 7 times that of his son. So Jacob's age 5 years ago, which is x minus 5, was 7 times his son's age, which is y minus 5. X minus 5 equals to 7 into y is 7y, plus into minus minus, 7 5s are 35. X minus 7y equals to minus 35 plus 5. X minus 7y equals to plus minus minus, 35 being the bigger number, minus sign will retain. 35 minus 5 will give us 30. Equation 2. So we have got both the equations. First equation, x minus y equals to 10. Second equation, x minus y equals to minus 30. Now we can use any of the algebraic method to solve the equations. Since we have applied elimination method in the first question, let's go with substitution in this case. Having said that, you can still opt for elimination method for this question as well. It's only that since we have already done elimination and we want to do substitution in this question, that's why we are opting for substitution. We can manipulate either of the equation 1 or 2. Let's go with equation 1. So equation 1, which is x minus 3y equals to 10. We can manipulate it to x equals to 10 minus 3y to the other side will be plus 3y. So 10 plus 3y. So let's mark this as equation number 3. Since we have manipulated equation 1, we will put the value of x, which is 10 plus 3y, in equation 2. So we'll put x equals to 10 plus 3y in equation 2. Equation 2 is x minus 7y equals to minus 30. So in place of x, we will write 10 plus 3y and rest of the equation as it is. Minus 7y equals to minus 30. Now the like terms, 3y and minus 7y, plus minus minus, 7 is the bigger number, so minus sign will retain. 7 minus 3 will give us 4. So minus 4y equals to minus 30, and this 10 will go to the other side. So sign will change, then we'll get minus 10. Minus 4y equals to minus minus plus, but sign will remain minus 30 plus 10 will give us 40. Since we have minus sign on both the sides, so minus sign can be cancelled, and we will get y equals to 40 by 4. 4 ones are 4, 4 tens are 40. So the value of y is 10. Now simply we will put the value of y equals to 10 in equation 3, which is x equals to 10 plus 3y. So in order to get the value of x, we'll put y equals to 10 in equation 3. So x will be 10 plus 3y. In place of y, we'll write 10. X equals to 10 plus 3 tens are 30. So x equals to 40. So we got the value of x as 40, which was Jacob's present age, and y equals to 10, which was his son's present age. So we'll conclude our answer by writing, hence Jacob's present age is 40 years and his son's present age is 10 years.